Hello everyone and welcome to this presentation. My name is Christina Chaccour. I'm a PhD student at the Bradley Department of Electrical and Computer Engineering in Virginia Tech. And today, as part of the CTech Squared program, I'll be talking to you about the Internet of Things. Let us first look at the evolution of the Internet. So traditionally speaking, the Internet was supposed to connect computers together to the World Wide Web so that people through these computers connect and share information. Nevertheless, as devices have become smarter, we started accessing the internet through smartphones, smartwatches, smart devices, wearables, sensors, etc. And this is making us look at actually things that are connected to the internet, starting from your home being connected to the internet, leading you to a home automation system, something like the thermostat with the temperature sensor that is linked to the internet. So it can be anything that is connected to the internet. Any smart device that is connected to the internet is actually shaping the internet in a different way from the traditional paradigm where only a computer would let you connect to the World Wide Web. And this is why this has led to an evolution. And we will talk about this in more detail. And then a more evolved way of the Internet of Things is the Internet of Everything, where instead of actually only connecting smart devices and smart things, we're actually connecting everything around our world. And our world is becoming kind of a global village. So Cisco has said, as the Internet is evolving, so will we. And this shows how our devices evolved over the course of time and how the Internet is evolving over the course of time, and how this will shape the world in a different way than it was 50 years ago or something like that. So now let us define the Internet of Things more strictly. So the Internet of Things, also known shortly as IoT, refers to billions of physical devices around the world that are now connected through the Internet. And this can be something as small as a pill or as a medical device that is injected inside the body of a human being, or to something as big as an airplane. And this shows how things around the world are now connected all together. As you can see in the picture in the slide, we have the agricultural sector that is automated through the use of Internet of Things, going up to smart transportation where we can see self-driving cars, up to home automated systems where we have all our homes kind of powered by something like Alexa, where your temperature sensor can regulate the temperature of your home, where so many things can be remotely automated in your home wherever you are. So why is the Internet of Things is so important? Because it allows us to gather big data. And what can we do with this big data? Well, we can do multiple things. Strictly speaking, this big data allows us to solve and control worldwide problems that engineers could not solve before, simply because if you do not know something, you cannot solve the problem, right? And if we want to save, for example, power throughout homes around the US, we need to know how Americans around the world behave. What are the trends and where we can actually benefit to save power? Whenever we aggregate all this data around all the houses around the US, and we know for sure that this age range uses their home throughout these hours, the other age range uses their homes for another hour, then we can understand how people are behaving around their homes and how those things should actually act. And this allows us, for example, to suggest power saving techniques by automating those homes and turning off many devices whenever those users are out of the house or something like that. Another thing is agriculture, and this is something so important. As COVID-19 has emerged, we have understood how much agriculture is important and how much it's important to put food on the table. And it's important to sustain agriculture for a long period of time so that we can survive on our planet Earth and keep it green. So in order for us to feed billions of people around the world, we need to make farming and agriculture smarter. And to do this, we should benefit from the technology that we are innovating in, and we should use sensors. So for example, with the use of temperature and humidity sensors, while knowing all the information that we need to know about a certain plot, we can smartly irrigate specific plants and let them only get irrigated whenever they're more or less, between quotation mark, thirsty, so that we don't over irrigate or under irrigate. This is one example. There are many other examples that can be done to provide precise farming and smart farming. So these are just two examples that I gave in regard to agriculture and home automation. You can come up with any other example that lets you understand how gathering data from sensors and from things makes our life easier and makes engineers and problem solvers around the world solve these problems in a much easier way. Because without data, we don't really know the reality of the problems. And now, as the Internet of Things is evolving, I've mentioned previously that we're getting to something called the Internet of Everything. And so previously, we had our homes automated, we had our cars connected to the Internet, we had our smartphones, our wearables connected to the Internet. Those were all things. But now we want actually more. We want to connect everything throughout this global village of our own, which is the World Wide Web, and which is our world. So once we actually monitor how people are behaving around the world and gather data from that, monitor how processes around the world are evolving in the course of time and how data is evolving over the course of the time, we can understand how our world behaves better. So for example, by monitoring how people behave even without those sensors, we can actually understand more stuff about user behavior that let us solve a long range of problems. But this all this luxury comes at a certain price, definitely. And there are many challenges that engineers and telecom engineers and the infrastructure that needs to be fulfilled in order to have this IoT dream come true 100%. So given that we're saying that all of those devices are connected, we need massive connectivity. Given that we're connecting people and the behavior of people is something that might need to be secure or private, we need to ensure that the data that we're gathering from people is only data that allows us to do some analysis without actually infringing the privacy of people. And the way the coverage of wireless communication is evolving. Another example is, so for example, if we're injecting a small medical device or a sensor in the body of someone in order to monitor something, some organ or some heart failure. In that case, in that particular scenario, we need a very low latency to ensure that this life and death matter remains sustained. Because if that sensor is late to send out the information to the medical doctor, then that person might suffer from a heart attack or from any health-related problem. So the requirements are of a wide range. Another example is that just like you all want to upgrade your mobile information, your mobile packages whenever you have a cell phone and you want more throughput and more data. Internet of Things sometimes in some wearables, like for example, virtual reality, where you want to be 100% immersed in your game. You need a very high throughput to be immersed. Otherwise, it will not be smooth. So as you can see, the range of requirements that are needed to be sustained are big. And this is why you hear about generations of communications, because we're evolving over the course of time. We're evolving from 4G to 5G, and next we will also have 6G. So how does it work as a big box? Okay, so first we need to collect data, and this data is collected through sensors that are equipped with things. For example, let's take an example of the temperature of your house, and you want to regulate it at a certain level. Okay, so the thermostat in your place will actually collect the data of the temperature every probably 10 minutes or 5 minutes, or depends on the interval that you want. And once so for example, let us assume that our problem is to regulate the temperature at 70 degrees Fahrenheit, right? Whenever the threshold is exceeded or goes below the threshold, we want to communicate wirelessly, for example, to your mobile phone that, dear sir or madam, the temperature threshold in your place has been exceeded or has went below the threshold. And sometimes it actually might communicate to a server that would act on his own. So for example, your house might be automated in a way that automatically the temperature is always regulated at 70 degrees. So in that case, that data is communicated to a server. That server then analyzes the data, and then the control is given. So for example, you either turn on the air conditioning system, or you turn on a heater, or whatever the course of action that needs to be taken. In this case, there's not really a big analysis of data, so it's easy to know what to do in terms of a temperature threshold. But take, for example, the case of COVID-19. People are gathering data all around the world, right? And in order for us to solve this big problem that is facing everyone in the world, we need the right tools to analyze data. Even though this presentation is not about the artificial intelligence, but I just like to give a small remark in terms of analyzing data. So in here, we need the right tools in order to understand the correlation between two events. To understand, for example, that given this age group, the likelihood of having severe symptoms from COVID-19 is high. So once we have those right mathematical or artificial intelligent tools that enable us to understand the relations under the data, we can analyze the data better, and we can provide a better control in the future. So the range of activities or the range of things that we can do with IoT and with the Internet of Everything is vast. It can be from something as simple as a temperature sensor to something as complex as COVID-19 cases, and analyzing the data in order to understand how we can solve this pandemic through the data. So for today, let us first go through a simple activity. The first one is actually aggregating data from our computers, from the processors of our computers, and understanding, and we'll just see how this data can be used later on for IoT. So the first thing that you should do is, hold on, excuse me. Yes. So the first thing that you should do is go to Jupyter Lab and open a terminal. So we go File, New, Terminal. And I specified two commands for you. So the first one is pip install STUI user. So whenever we want to code something, the first thing that you want to do, and this is here, and this is first the terminal, and here we're writing in Py. The first thing that you would like to do is to install anything that your coding environment would need. So the first thing that we will do is to do this installation. So here it shows us that there's a progress, it's downloading, it's successfully built everything, and it's downloaded. Okay, now we are ready to actually execute any code that allows us to access data. So in here, we will use this already ready package, which allows us to analyze data. So as you can see, now I have a graph here of all the cores, how they're being used, right? So for example, see, as I'm hovering my mouse and opening new stuff, you can see that there is a change in the number of cores that is used. Now, how is this useful to the Internet of Things, you might ask me? So this is how we're actually collecting the data. The first step in the Internet of Things process. Given that this session is given online, we cannot actually send it to a sensor, to a server where we'll actually act on it. So now we know actually how the cores of my computer are working. If we aggregate information from my computer, your computer, and differently many other computers, we can understand a lot of things about computer failures, CPU failures. So here we can see, for example, the the frequency, and the cores of everything, right? So these all allows us to understand stuff about our computer. I just wanted to give this simple example that allows us to understand what's going on in your CPU. So how do manufacturers actually traditionally used to perform better testing on their processors? They would hear out feedback and they would provide better tools based on the feedback they've heard. But now with big data, they can actually aggregate data from differently many users around the globe and understand that, okay, someone in a lot of people in this area with this chip in their computer faced this type of failure and they would work on it. So big data is mainly there to let us solve problems that we were not able to solve. So many times data allows us to have insights that with our human eye or from the behavior that is going on, we could not see. So this is one example. Now, the second activity that we will do is related to what is happening now, which is COVID-19. So I prepared the second activity for you guys on a notebook. And all you have to do is have it downloaded on a desktop or on a file in your computer. And you just need to drag and drop it here. Once you do, first let us close this window. And then we can open the activity. Okay. So my main goal from this activity is to collect COVID-19 data, okay? And similarly to the first example, in here we also need to install stuff from the internet so that we can do the installation. So we can perform any data collection. So here we can see that we still have a star. It means that it's still loading. So it's installing all the packages. Okay, we're done from the installation. Now we need to import all the things from those installed files. So in here we run this as well. And then it's important to collect data from reliable sources so that our analysis reflects what's going on. So to do that, we collect information here from some reliable source, and then we do some cleaning for the data so that we can actually put them in a table. And then in here, you know that a confirmed case needs to be an integer. So I won't go into the details of the code. So after we collect this data and understand what we have a country column, a confirmed column, death column, and recovered column. After we filter the data well, we want to display the total stats. So now at this point where I'm doing the simulation, we have around 10 million confirmed cases and half a million of deaths. And then let's say that we want to visualize our data. So here we can see that we have here a box called N. We can change it based on our preference. And one also other notice is that this code is not mine. It's a code that has been developed and put on GitHub, but I felt that this is a good simulation that you can guys see in order to understand the dynamics of the Internet of Things and how we can use data in order to do IoT experiments. So in here we can see the confirmed death cases in the US. So we're producing these based on the source that we got the information from. And then after that, let us sort our data so that we can understand the best and the worst hit countries. So now we're sorting whatever cases we had here, and then we're plotting them in a graph. So in here we can see the worst hit countries, and it actually gives you see that sometimes plots give you a more visual way of seeing things. So maybe if you look at the numbers in here, you might not understand how much the US is leading in confirmed cases. But once you actually see this in a graph, you can understand how much here we have more cases, how much Brazil is leading, how much Russia is leading compared to other cases. We can also increase the number. Anyway, so yes. And then we can have some other visualization done. So for example, in here we can finally have a world map of our own, as you can see. You see? So now we produced our own world map for COVID-19, where we can see all the confirmed cases. And this is all done by collecting the data from reliable sources. So how is this related to IoT? Well, if we actually visualize the data in a smart way, and we understand the correlations between the number of deaths and the number of age groups, we can also extend this to something called contact tracing, so that we understand that this person who had this phone has a COVID-19 case. We want to make sure that that person did not meet with other people. So for example, let's say that person X has COVID-19. If we do monitor their phones closely, we can know if their phones were at a close proximity of other people's phones. And then we can understand whom they have contact with and how we can, where we should do testing. So it's not only aggregating data from a reliable source that we got from a website here, but it's actually also extending this to contact tracing to solve this problem. So the main thing is that data is a very powerful weapon that we should use to our benefit. And the Internet of Things has enabled us to gather data that we did not have access before. That's the main thing. So previously, all the data that you could have gathered was from computers, from surveys that you would do with people, like you would ask them questions. But with the IoT, you're capable of taking raw data, extracting the location of users, extracting information about other countries and their cases of COVID-19, understanding a lot of correlations. So all this big data that we're gathering allows us to solve multiple other problems. And here in this example, we were not capable of showing you how we can actually control a device. How, for example, based on a certain temperature sensor, we can turn on or turn off an air conditioning system simply because we were limited to an online session given this pandemic. But the reality of things is that the first and most important goal is to collect raw data from good sources, analyze that raw data, send it out to the right server and analyze it, and then provide the decision making that you should make, the control that you should make in order to solve a lot of things around you and to understand a lot of correlations that exist around us. That will be it for our session. Thank you so much for attending this presentation. And if you have any presentation, please feel free to contact me at christinac@vt.edu. Thank you so much.